Section 5.2, we're going to talk about graphing linear functions, graphing lines, basically. What do you know about graphing lines? If I were to give you an equation, I'll make up an equation here. Y equals minus 2x plus 3. First off, how do we know that's a line? How do we know that's linear? Everything's to the first power. There's no exponents, there's no square roots, there's no fractions with variables on bottom, there's none of that stuff. All right, so that's definitely linear, so that graph is going to be a line. How do you graph that? Okay, so why do you start at positive 3 on the y-axis? All right, so in previous classes, I'm guessing you did this in Math 1230, you learned that this number right here gives you the y-intercept. So that value right there gives you the y-intercept. The y-intercept is 0, 3. And then what's that number negative 2 called? That's the slope. All right, so what does slope tell you? All right, so slope, we quite often remember it as rise over run. Okay. We usually use the letter M for it. I'm not sure why slope starts with the letter M, but it does. What else do you know about slope? Well, it can be exponential, but then it wouldn't be a line. To be a line, the slope is always exactly the same. So for this line that I've written here, the slope is always the number negative 2. If you have an exponential functions also have slope, but their slope changes. And when you take calculus, you'll learn about slopes of other kinds of functions. But not today. What else do you know about slope? If I tell you the slope is negative 2, what does that tell you about that line? What's that line going to look like?
It's going to be like downward.
It's going to be downward. How do you know this one's going to be downward?
The number's negative.
Because the slope is negative. So the slope tells you the direction. If the slope is negative, the line goes downward. When does the slope go upward? I'm sorry, when does the line go upward? When the slope is positive. So the slope tells you direction, up or down, upward or downward. Increasing or decreasing are the fancy math words that we use. The other thing the slope tells you is how steep the line is. A line with a slope of 2, or negative 2 in this case, is that a pretty steep line, or is it a pretty shallow line? Shallow? Well, I guess steep and shallow is kind of a relative term. Personally, I think of negative 2 as actually being a pretty steep line. A shallow line to me would be a line that had a slope of like 1/3. A line with a slope 1/3 would be pretty horizontal, where a line with a slope negative 2 is, to me, pretty steep. Well, let's draw a picture and we'll see who's right. All right, so 1, 2, 3, negative 1, negative 2, negative 3. 1, 2, 3, negative 1, negative 2, negative 3. Okay, so you told me I start at the point 0, 3 because that's the y-intercept. That's right there. And then you told me my slope is negative 2, and I'm pretty sure you said go down 2 and then right 1. Is that what you said? That's exactly correct. So I start here, I go down 2 over 1. And then I could do it again. I could go down 2 over 1, and I could keep doing it as much as I want. I think that's enough. I'm going to play connect the dots. And there's my line. So personally, I think that line's actually kind of steep. So I would say it's kind of steep. Of course, it's not as steep as a line that had a slope of negative 10. A line that had a slope of negative 10 would be much more steep than that even. Okay? Questions about that? Okay. What if we went the other way? What if I drew you a picture? So here's my line. It looks just like this. And I told you that this right here, this is the point 0, 2 maybe. And this right here, this looks like the point 3, 4. If I gave you that picture, could you turn around and tell me what the slope is? Yes. How could you tell me what the slope is? All right, why do I do 4 minus 2 and then 3 minus 0? That's absolutely correct, by the way. All right, so there's a famous little formula that we use for slope a lot. And it's m equals y2 minus y1 over x2 minus x1. And I'm going to write here, not I see students write that a lot for slope, and it bothers me. And when things bother me, I take points off. So you want to avoid that. What's wrong with this? What's the difference between y with a 2 up here and y with a 2 down there? What's the difference in those? The first one means, this one means y squared. And what does that one mean? It's a subscript, which means it's the second y number. Yeah, it's just, so this one means take the second y number minus the first y number. And this one means take the second x number minus the first x number. Where this one means take y squared minus y to the first, and take x squared minus x to the first. Very, very different things. The placement of these numbers, either a superscript or a subscript, makes a huge difference in math and means very different things. So if you rate this on a quiz or on a test or on a homework or anything, I promise you I will take points off. The numbers need to be down at the bottom. They're not exponents, they're subscripts. All right, so we find the slope. And you said to do 4 minus 2. So you decided that this number was y2. Could that number be y2? Yeah. It could be. The order that you do it in doesn't matter. What does matter is if I use this y number first, I have to use that x number first. That's really the only thing that matters. Stay in that order. And it matters that you put the y's on top. A lot of times I'll see people put the x's on top. That's no good either. Over 3 minus 0. So this looks like this line has a slope of 2/3. Okay. To me, one of the first things I do, especially when I have a picture, when I find a slope, is I ask myself, does that look reasonable? Well, first off, I looked at this picture, and I did know the slope should come out to be positive. How did I know the slope should be positive? The direction, the line goes upward. It's increasing. And then 2/3. Well, 2/3 is kind of a smallish number, so I would expect this line to be kind of flat, not very steep, and it looks kind of flat to me. So that looks like a pretty reasonable number. If I had gotten negative 2/3, I would have known right away I made a mistake. There's no way that slope could be negative. And if I had gotten, say, 10/3, I would have thought, well, that's probably wrong too. That's too big. Okay. Now that we know the slope, can you tell me the equation of this line? Yeah?
Y equals 2/3 x plus 2.
And how did you get y equals 2/3 x plus 2?
Because 2/3 is the slope and the y-intercept is 2.
Yeah, and we use this little formula like we did before. And it's usually written this way: y equals mx plus b. And that has a name. What's that called? This is called slope-intercept form of a line. So our answer would be y equals. We know the slope. The slope is 2/3. We know the b number. We know the b number is 2 because that's where the y-intercept is happening. And so there's our answer. Y equals 2/3 x plus b. Questions on that? Okay, so our spring is being stretched, and x is our distance in inches. So if we stretch it If it's stretched 1.4 inches, it takes 58 pounds of force. If we stretch it to 3 inches, it takes 162 pounds of force. The directions are find the slope in attach proper units. So when we go to find the slope here, which one's x and which one's y? Well, for this one, I think it's pretty obvious which one's x. Which one's x? The one I called x. That's right. And which one's y? F. What if this one wasn't called x? What if this one was called q?
And it would still be x because inches is the length.
Correct. In general, when we give you a table, either, it depends on which way we orient the table. If we give you data across this way, the one on top is always the independent variable, it's always the x's. And the one on bottom is always the dependent variable, it's always the y's. Conversely, sometimes we give data in this form. So I might have written x and f, 1.4, 3.0, 58, 162. Again, if I give you data in this format, the thing that comes first is always the x, always the independent variable. The thing that comes second is always the dependent variable, always the y. So by the orientation of the table, you can tell. All right, so our slope would be, what's the answer? What do I write?
1.6.
Say that again.
104 pounds over 1.6 inches.
Okay, so you did all the arithmetic already. So you did 162 minus 58 divided by 3.0 minus 1.4. And you told me 162 minus 58 is 104. Divided by 1.6, you said? Okay. Okay, that's a correct answer. Almost. All right, so that's the almost part that I don't like. Generally, when we have a fraction, we don't mix fractions and decimals. We either do all fractions or all decimals, one or the other. The other thing it said in the directions was interpret your answer as a rate. So I think it would be easier to simplify it to interpret it as a rate. So how would you simplify that thing? I'd grab my calculator and I would type in 104 divided by 1.6. And my calculator says that's 65. Turns out to be a pretty nice number, actually, 65. 65 what? What are the units?
Would it become per square inch? Or would it become per inch?
Okay. Well, remember, we put the y's on top. In this case, what were the units on the y's? It was pounds. And then we had the x's on bottom. What were the units on the x's? Inches. So it looks like the units are pounds per inch. In other words, it takes 65 pounds to stretch that spring 1 inch.
It says it only takes 58 pounds for 1.4 inches.
Well, you're absolutely right. When we took it from rest and went to 1.4 inches, it says it only took 58 pounds. So why, if we go from 1.4 to 3.0, it takes 65 pounds per inch? That's a good question. Anybody have an answer? True. All right, so notice in the directions it said within certain limits, the force is a linear function. So I think what happens when a string is fully relaxed, it doesn't take quite as much force to move it to begin with. But the more you stretch it, the harder it gets.
So it's like an average.
So it's kind of like an average. So you're exactly right. What this is telling us is, on average, it takes 65 pounds every inch. It doesn't necessarily mean it takes exactly 65 pounds every time you move it 1 inch.
One would be, first one would be the initial force, and the next would be the limiting force, if you will.
Correct. You could consider this initial force and consider that terminal force. Initial distance, terminal distance. Yep. All right, so the next one is very similar. It says assume the value v of a car is a linear function of its age t. And it gives us a table. We have t, which is in years, and v, which is in dollars. And at 0 years, we bought a brand new car. And when we bought a brand new car, apparently we paid $15,000. That's relatively inexpensive for a brand new car these days, but okay, I'll take it. And then 4 years later, our car was worth $9,000. So again, it wants us to find the slope and interpret it. So what would you do to find the slope in this case? $9,000 minus $15,000 over 4 minus 0. 9,000.
Or, no, -6,000.
Negative 6,000 over 4, which is negative 1,500. And again, what would the units on this be? Dollars per year. All right, so what does that mean? The value drops 1,500 per year. And again, does it mean that the value drops exactly 1,500 every single year? No, it means on average over those 4 years, it lost 1,500 the first year. In fact, what happens when you buy a brand new car and you drive it off the lot? It loses a whole bunch of value. As soon as you put the key in it and drive it off the lot, it loses a lot of money. But then after that, for the first few years, it doesn't lose a whole lot. So most of this loss happens right at the beginning. Kind of a bad deal if you buy a brand new car and then you wreck it a week later. You get about 2/3 the value of the car from your insurance, which is very disappointing. All right, so what's next? Y equals mx plus b comes up next here. We talked about that. Graph the line using the slope and the y-intercept. We did that already. Okay. Move on to page 3. It says, 2 forces are acting on a beam. Satisfy the equation 3F1 equals 5F2 plus 20. Express F2 as a function of F1 in the form F2 equals MF1 plus B. All right, so kind of strange directions there. What does it mean when it says express F2 as a function of F1? Right, what it really means there is you want to get F2 all by itself on one side and have all the other stuff on the other side. So if I ever say express F2 as a function of F1, that means I want F2 all by itself on one side and a bunch of stuff on the other side that has F1 in it. I might also simply say solve for F2. Solve for F2 means get the F2 all by itself on one side, other stuff on the other side. All right, so how would you take this equation and get the F2 all by itself? Subtract 20. So 3F1 minus 20 equals F2, equals 5F2. Divide by 5. And when you divide by 5, be careful. Perfect. You have to divide everything by 5. A very common mistake that I'll see students make is they'll take the 20 and divide it by 5 and write it as 4, which is good, but then they'll take the 3 and they won't divide it by 5, they'll forget. So unfortunately, we're going to end up with a fraction here. We're going to have 3/5 F1 minus 4 equals F2. All right, so now we're going to draw a graph. We're going to have, which letter is X and which letter is Y? How do you know y is f2? Because we solved for it. Usually we write y equals a whole bunch of stuff, right? So now we have f2 equals a whole bunch of stuff. So f2 is the y variable, the dependent variable, and f1 is the x variable, or the independent variable. All right, so where's my intercept? 0, -4. Excellent. An intercept is a point. It needs an x number and a y number. 0, -4, 1, 2, 3, 4. I'm going to go right there. And since mine doesn't have scaling on it, I'll just label that point 0, -4. And then what do I do? I go up 3 and over 5. So I go up 3, 1, 2, 3, and over 5. 1, 2, 3, 4, 5. What point is that right there? It's 5 because I went to the right 5, and you told me it's -1. Why is it -1? Because I started at -4 and I went up 3. That makes it -1. All right, and I connect the dots. Not very straight, but not too bad. Do you like that graph? That's not a very good way to ask that question.
I did 5 and -1.
How did I get the 5 and -1? All right. He told me. No. To get the 5 and -1, I used my slope, right? So I started at -4, and I went up 3 places. So if I start at -4 and go up 3 places, where am I? -1. And then from there, I went to the right 5 places. So my x's, I started at 0, and I went right 5. Of course, if you have, on the piece of paper that you have the grid there. So if you go up 3 and over 5, you can also kind of look at where it is on the grid and see it's better.
Okay, thank you.
You're welcome. Here's what I'm thinking that I'm not terribly thrilled about. Do we really usually talk about having a force of -4? I mean, I suppose we can. If you look at the picture that's given, the picture looks like this. Basically, you've got something balancing, so you've got force 1 going this way and force 2 going that way. I guess we could talk about a force being -4. I guess what it means for the force to be -4 is it's not going down, rather it's going up. But I'm not real thrilled with this graph because it seems a little awkward to have forces being negative. So probably this graph, the part you would truly want, would really just be the part over here in the first quadrant. But I didn't leave myself enough space to do that, so I'm not particularly thrilled with the graph. Is it a correct answer? And if you were to draw this on your quiz or on your test, would you get full credit? Absolutely, it's a correct answer, and you would get full credit. But for this problem, I don't think it's a very good graph. I don't think it makes a lot of sense. I think it would be much more meaningful to just draw it in the first quadrant and have that part. But too late, I already drew it, so I'm going to live with it. The next problem says, an object is thrown upward with an initial velocity of 50 feet per second. Then its velocity v in feet per second, t seconds later, is given by the equation v equals 50 minus 32.2 t. The dependent variable is v, since the velocity depends on the time. Okay? Then it asks us to find the y-intercept, or in this case, we really should call it the v-intercept. Okay, so what's the v-intercept? 50?
Yeah.
50's half right. Remember, an intercept is a point. It needs an x number and a y number. So is it 0, 50, or is it 50, 0? 0, 50. Y-intercept always has x, 0. So the v-intercept in this case is 0, 50. So to find the v-intercept, really what we do is we plug 0 in for the t number. If I plug 0 in for the t number, that's all 0, so I get v equals 50. Then it asks us to find the x-intercept, or more properly for this problem, we should call it the t-intercept. How do I find the t-intercept? I put 0 in for the other letter. So if I ever ask you to find an intercept, that always means plug 0 in for the other letter. So finding the t-intercept means v equals 0. So if v is 0, I have the equation 0 equals 50 minus 32.2t. How would you solve that equation? Subtract the 50, so minus 50 is minus 32.2t. I divide. Calculator says, all right, let's see. It just says find the intercepts. It doesn't tell me how many decimal places I should round off to.
Problem was 0.2.
The problem, however, does, doesn't it? Because we're given one significant digit here, 0.2. So I got 1.55, so I guess I should call it 1.6. Seems reasonable, like I should keep my significant digits. So that would be 1.6, comma 0.
Is it negative 1.6?
No, it should be positive because negative 50 divided by negative 32.2. Two negatives make a positive when I divide. Should be positive. What do these mean? V-intercept, 0, comma 50. What does that have to do with this problem? At time 0, the velocity was 50. Correct. What does the t-intercept mean? At time 1.6 seconds, the velocity was 0. If a thing's thrown up in the air, how can it have velocity 0? That's when it reaches its peak. That's right. So another way to read this is the object reaches its peak in 1.6 seconds, and then it starts to come back down. So that's what happens. The rock goes up, it stops just briefly, just for an instant, and then it turns around and comes back down. This is the stopping point. This is the turning around point. All right, wants us to graph. And it gives us a picture, something like this. Graph this function by plotting the two intercepts and connecting them with a straight line. Scale and label your axes so the graph fits in the space provided. All right, so where should I put the v-intercept? Where's 0, 50? There's no scaling given on the graph. So where would you put it? 5 spaces up, which is kind of close to right in the middle, isn't it? That's good, I would think. All right, so I'm going to put mine right about halfway up, I guess. Lost my blue pen. There it is. 0, comma 50. And this is V, and this is T. Now, how would you scale your t-axis to be able to label 1.6? Maybe by 0.4s. That would be pretty good because we'd hit exactly 1.6. All right, so this is 0.4, 0.8, 1.2, 1.6. So sometimes it does make sense to scale your axes using decimals. And I think this is a great example. You don't always scale your axes as 1, 2, 3, 4, 5. Sometimes decimals and fractions are actually useful for scaling. All right, so we put a dot right there. And then once again, we play connect the dots. So the line itself would look like that. Then it asks a question. Why do you think that in the picture, only quadrants 1 and 4 were included in this problem? Go ahead. Correct. Remember, this stands for time 0 right here. It doesn't make any sense to talk about where the ball was at time -1 or time -2, so on and so forth. So really, a better picture would probably be not to draw the whole line, but rather just draw the ray. That would probably make more sense. And then on the other hand, is this going to go like this forever? Eventually it's going to hit the ground, and it's either going to stick in the ground or it's going to bounce. So probably I should have drawn this, and the issue is I don't know where I should stop, but I probably should have stopped right here, and I shouldn't have continued on forever. So a more realistic picture would look like that. But that's not what they told us to do. They told us to draw the line. So I do the line, I do the whole thing. But again, for this situation, I don't think it's really a great picture. Probably should have started there and stopped about there.